Hello everyone, welcome to this video where we are given the vertices of this triangle PQR with the diagram also provided. And for part A, we are supposed to find the length of PQ, QR and RP. And actually part B is related to part A because from there we could actually make use of the answer in part A to show that this triangle is in fact a right angle triangle. And because we know that it's a right angle triangle, it becomes pretty straightforward to find the area of triangle PQR. Yeah? And for part D, to state the coordinates of this point S, whereby PQRS is a rectangle, this one will require us to look at the diagram itself later on. So without further ado, now that we have successfully know the approach to solve this problem, I will first start off with part A of this problem. So for part A, we are given all the points, yeah? So all I have to do is simply for PQ, I'm going to just apply the formula where this will be my x1, y1, this will be my x2, y2. So from here, I would be able to get my PQ pretty straightforward. It is simply the square root of x2 minus x1 plus y2 minus y1 square. And this will give me a value of 68 square root, which will be equals to 8.2462 to 5SF followed by 3SF. 8.2, since this is 6, then my 4 will become 5 units to 3SF. So that is for PQ. Let's move on for the QR. So with QR, again Q, I like to do this so that I will not make careless mistake. So R is 5.2. So this is what I would do so that when I find my QR, I will be very clear. My x2 minus my x1 bracket square plus my y2 minus my y1 bracket square, and this will be equals to square root 17, which will be equals to 4.1231 to 5SF followed by answer in 3SF, 4.12 units. Next length that we are supposed to find would be my RP. So my R is 5.2 and my P is -4.4. So again, I'm going to just repeat this for the third time. Okay, so RP will be equals to the square root of -4 minus my 5 bracket square plus 4 minus 2 bracket square. This will be equals to square root 85, which will be equals to 9.2195 to 5xf, significant figures, followed by 3sf, and because this is 9, so it will be 9.22 units, rounded off to 3sf. And we have just completed part A. And now, from part A, with these 3 length, we are then be able to solve for part B to show that this triangle is indeed a right angle triangle, okay, by using the converse of Pythagoras theorem. Okay, so I am going to create a space now for my part B. So part B will be here. Let me just draw a line. Alright, so for part B, then I noticed that the RP is the longest line. So this is what I'm going to do. I'm going to first find what is my PQ square plus QR square, which will be equals to square root 68 bracket square plus square root 17 bracket square, and this gives me a value of 85. I also have to go and find my RP square, which is equals to the square root 85 bracket square, and this also gives me a value of 85, which is the same as PQ square plus QR square. And because they are the same, since PQ square plus QR square thus equals to RP square, with the above working, so from here we are able to conclude that this triangle PQR is a right angle triangle by the converse of Pythagoras theorem. Okay, this is an important statement here. We do need to let people know by which theorem does we use to conclude this, and we also do need to indicate why, which is here. Okay, so these are the key words for this particular part B. And the moment we know that this is a right angle triangle, then for part C, we would then be able to solve for part C pretty straightforward, because if I were to redraw this triangle, I would then know that this is my right angle, this is square root 85, and QR, so this is my Q, this is my R, this is my P, so QR is square root 17, this is square root 68, so the area of triangle PQR is simply half time base times height, yeah, where the base is 68, the height is square root 17. this will give me 17 units square. And for the last part of this question, it will be good for us to just have a look at this particular diagram again, which I am going to just snip it out and do some manipulation. Oops, sorry. And to do some manipulation, so give me a moment. I'm going to shift this over. For my part D, which is here, I need this. So for part D of this particular problem, we are supposed to find this particular coordinates of S such that P, Q, from P, Q, R and S is somewhere here, is a rectangle. Yeah. So it is important for us then to, will be good for us to make use of the diagram given. Okay. Since rectangle, right, means that it is going to be a parallel line. That means this line and this line that we are going to draw later on. How do I make sure that it is a parallel line? This is what I'm going to do. I am going to make sure that I know from 4 units to 5 units. Here is actually 1. It moved from 4 to 5, 1. And then to go down to point R, it actually moved from 6 to 2, 4 units down. And that is exactly how we are going to make sure we get the S using this. From point P, I just need to make sure I move 1 unit to the right. And oops, 4 units down. Okay, so I'm going to just make adjustment to my just now my rough drawing, and that's where we are able to get my point S now. My point S is here. Okay, and so from here you could actually see that this point here is -3. Or should I use blue color? Yes, I should use blue color. This point here, because from 4 move down 4 units. If I were to move down 4 units, it will just be at 0. So I have actually successfully identified my point S. So if I were to just draw this out, this will look something like this. Yep. So for part D, I have successfully gotten my coordinates of S, where the X coordinate is -3 and my Y coordinate is 0, purely from observation from the diagram itself. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.